The pre-mechanical age, spanning roughly from 3000 BC to 0.1450 AD, was the earliest dot period of technology where communication and information processing relied on human interaction, and the use of symbols, images, and early mechanical devices. Writing in alphabets, petroglyphs, signs, or simple figures carved in rock. Ideographs, symbols to represent ideas and concept. Cuneiform, the first true written dot language and the first real information dot system, cuneiform. The first calculator. Abacus was man's first recorded adding machine, invented in Babylonia and popularized in China. The mechanical age of computers, roughly 1450 to 1840, was a period marked by the invention of machines that automated calculations. First information explosion, Johann Gutenberg, movable metal type printing process in 1450. Napier's bones, or Napier's rods, are a set of graduated rods invented by Scottish mathematician John Napier in 1617 for performing multiplication and division by transforming the operations into addition and subtraction, respectively, a method also known as rhabdology. Wilhelm Schickard, -1623, professor at University of Tübingen, Germany, invented the first mechanical calculator that can work with 6 digits and can carry digits across columns. William Ottard, 15751660, invented the slide rule. Blaise Pascal, 1642, invented the Pascaline, made of clock gears and levers that could solve mathematical problems like addition and subtraction. Gottfried Leibniz, 1617, invented stepped reckoner that could multiply 5-digit and 12-digit numbers, yielding up to 16-digit numbers. Mechanical loom, invented by Joseph Marie Jacquard in 1804, controlled by punch cards that describe the design of the textile precursor to programming. Charles Xavier Thomas de Colmar, 1820, developed Arithmometer, the first mass-produced calculator. The electromechanical age of computing, circa 1840 to 1940, was a period characterized by the development of technologies that harnessed electricity for information processing, leading to early forms of automated data handling and the foundation for modern computers. Key inventions like the telegraph and telephone were central to this era, enabling faster long-distance communication. And here are some examples of people and their inventions that changed the world and made a big impact on how we live today. Johann Gutenberg invented the movable metal type printing press in 1450, which allowed books to be produced faster and more easily. This invention helped spread knowledge, ideas, and education to more people, starting a major growth in learning and communication across the world. Later, Samuel F.B. Morse created the electromagnetic telegraph in 1832, a device that made it possible to send messages over long distances in just a few seconds. Along with the telegraph, Morse code was developed as a way to send letters and numbers using dots and dashes, which made communication faster and clearer, especially during emergencies and in the military. In 1879, Alexander Graham Bell developed the first working telephone, which changed how people connected with each other. Instead of writing letters or sending messages, people could now talk directly from one place to another, even if they were far apart. A few years later, Guglielmo Marconi discovered that electromagnetic waves could travel through space, leading to the invention of the radio in 1894. This allowed people to send news, music, and information wirelessly, making communication possible across the world. George Boole, in 1852, created a system of logic known as Boolean algebra, which became the foundation of modern computers and digital technology. His work made it possible for machines to think and process information, forming the basis of how computers operate today. Around the same time, Dörfelt built the comptometer in 1885, a mechanical device that could add and subtract quickly, making calculations easier for businesses and workers. Otto Schweiger followed in 1893 with the Millionaire, a calculator that could perform 4 mathematical functions automatically, helping people solve complex problems more efficiently. These inventions and discoveries are the building blocks of modern technology. They made communication faster, spread knowledge more widely, and helped people solve problems in new ways. Together, they transformed society and continue to influence the tools and devices we use every day. The electronic age, roughly spanning the 1930s to the 1980s, was a period of technological advancement driven by the invention of the transistor, leading to inventions like transistor radios, televisions, and early computers. Here are the examples of important people and their inventions that greatly contributed to the world. Konrad Zuse, in 1941, built the first programmable computer called Z3. This invention made calculations faster and easier, helping scientists and engineers solve complex problems. In 1942, Howard Aiken developed the Mark I, one of the first stored program computers. It improved how information was processed and stored, leading to more advanced machines. These inventions became the foundation of modern computers, making communication, work, and learning faster and more efficient. Computers are classified by purpose, general purpose, versus special purpose. Type, digital, analog, or hybrid, size, capacity, supercomputer. Mainframe, mini, microcomputer, and architecture, for example. Flynn's taxonomy: SIST, SIMD, MIST, MIM. Computers can be classified based on size, work, and purpose. Each type plays a vital role in our daily lives. Micro, mini, mainframe, and supercomputers differ in power and capacity, serving tasks from personal use to complex scientific research. Based on work, analog, digital, and hybrid computers process data in different ways, improving accuracy and speed. Special-purpose computers perform specific tasks, while general-purpose computers handle many functions. This classification helps us choose the right type of computer for various needs, making work, research, communication, and problem-solving faster and more efficient.